Welcome to Mbakwa Phosphate Academy of Science and Technology. I am your brother Mbakwa Phosphate, as popularly called by my students. We can teach you online at any time when you are free. You can contact us at 679953185, 6644632257. You can equally email us at mbakwaphosphate@gmail.com. I will be looking at reaction mechanism with you today. What is reaction mechanism? A reaction mechanism is a sequence of elementary steps that lead to the formation of product. Sequence of elementary steps. Sequence of elementary steps. That will lead to the formation of product. So in a reaction mechanism, it is simply the explanation of how a reaction takes place. If I have A plus B producing C plus D, the reaction in reaction mechanism will be interested to see which bonds are broken in A and B and which bonds are formed in D and C. That's all about reaction mechanism. Remember, I told you that in chemistry, organic chemistry, if you'll be able to know your homologous series, you are able to know your functional group, that of course a functional group is simply an atom or group of atom or a bond which is responsible for the chemical properties of a particular homologous series. So if you know a functional group, the different functional group, and now you know how to convert from one functional group to the other, the reaction conditions, the reagent, you are already a master of organic chemistry. That's how I explain it. So in organic chemistry, we will be interested to move from one homologous series to the other. What is the reaction conditions? What are the reagents? What is the mechanism of the reaction? Now, if you are able to write the mechanism, then you are an organic chemist. And in this lesson, we will be looking at addition reaction. We will look at addition reaction, and we are going to see that there will be two types of addition reaction. We'll look at electrophilic addition reaction. In electrophilic addition reaction, we will be looking at reaction that will proceed with the formation of a carbocation. Reaction that proceed with the formation of a carbocation, and reaction that will proceed with the formation of a pi complex. Those are the two, in this electrophilic addition reaction. This is what we are going to see. Now, we will also look at nucleophilic addition reaction, where a nucleophile will be added to an unsaturated compound to produce a compound that is saturated. That will be nucleophilic addition. Now, let us move ahead a little bit. Of course, reaction mechanism is a sequence of elementary steps that lead to the formation of product during a chemical reaction. It is an explanation of how a reaction takes place. I've explained that. In a reaction mechanism, some bonds are broken while others are formed, depending on the type of reaction. I have shown that already. Reaction mechanism. Addition reaction. So in addition reaction, we will see that we can have a reaction as our normal reaction, ethene reacting with chlorine to give us one 2-dichloroethane. 1,2-dichloroethane. This is an addition product. This is an addition product. This compound is unsaturated. In this compound, we have the pi bond and we have the sigma bond. We see that the pi bond here, whenever you see a double bond, there's a pi bond. This carbon is sp2 hybridized. Of course, there are many of my videos on hybridization. You can check them out. There's also a video on the type of bonds in organic chemistry. I've talked about the sigma bond and the pi bond. Now, if you are new here, you can consider subscribing so that our videos will always be sent to you directly. Now, when this chlorine molecule, 2 chlorine atoms successively, they are added to 2 carbon atoms. This is an addition reaction. This compound is unsaturated. 1,2-dichloroethane is saturated. Just like I was telling you that in reaction mechanism, we are looking at what is therefore the condition for us to move an alkene, which is unsaturated, to an alkane, which is saturated. Remember, what defines this homologous series is the general molecular formula CN H2N, and the functional group here is carbon to carbon single bond. Now, what defines this homologous series of the alkane is CN H2N plus 2, and of course the alkane do not really have a functional group, only the fact that you have carbon to carbon single bond and carbon hydrogen single bonds. So this is in reaction mechanism. We will be interested to see the elementary steps that are going to be followed in order to move from an alkene to an alkane. If we are talking about addition reaction, or an alkynes to an alkane, or an alkynes to an alkene, or an alkynes to an alkane, which are the elementary steps and what are the reaction conditions, and then we'll be able to now conclude about the reaction. We can only conclude about the product when we have written the mechanism of that particular reaction. We want to look at electrophilic addition reaction. In this reaction, an electrophile. What is an electrophile? An electrophile is a positively charged species. Here you have seen the electrophile as such. This is an electrophile. Electrophile. Yeah, an electrophile. We can also have species like this. These are electrophile. Now, so an electrophile is simply a positively charged species or a neutral molecule with an electron deficient center. You can see this boron here has an electron deficient center. Aluminium has an electron deficient center. Take note. So in electrophilic addition reaction, what we are going to be adding is an electrophile. Let's take for example the reaction of ethene plus hydrogen bromide to form CH3 CH2. This is BROMOETHANE. What is the mechanism of this reaction? Now, the mechanism is very simple. This mechanism, we observe that ethene plus hydrogen bromide. Now look, this bond here, is polar. Why do we say it's polar? The electronegativity of bromine is higher than that of hydrogen. So bromine atom is going to pull this bonded sigma bond more toward itself. This is what is going to be happening. It's going to pull this bond more toward itself. As a result, this bromine becomes slightly negative and this hydrogen becomes slightly positive. And the pi bond here is now going to attack the hydrogen. Yes, you see it here. The hydrogen, the slightly positive proton here. And when this happens, a bond is going to be established between the carbon atom, this carbon atom 1, let me number the carbon atom, this carbon atom 1, and a proton. And this is what is going to happen. Observe carefully. This is what happens. A new bond is established between carbon 1 and the proton. Remember that carbon 2 is now deficient of what? The electron, because all the pi bond here has been carried to establish a bond here. So this carbon becomes positively charged. This is a carbocation. Now this carbocation the carbocation now that is formed in the presence of this bromine negative, it can now do what? Come and attach itself here. When this happens, we are going to have a compound that is formed CH3 CH2 bromine is added here. This is an addition reaction. This is bromoethane that is formed. You can see the sequence of elementary steps that we have been able to move from the reactant to the product. This is the mechanism for the formation of bromoethane from the reaction between ethene and the hydrogen bromide. Why do we say is electrophilic addition? Because we add across the double bond, so we have added an electrophile, H plus, remember, H plus. This is the electrophile we are added across the double bond here, the pi bond. This is called an electrophilic addition reaction. That is A. We want to go to B. Dear students, if you are new here, you consider subscribing so that in our next video, you will quickly get it. Make sure that you hit the subscribe button and equally like the video. B types which proceed with the formation of a pi complex. This is an example of the kind of reaction we call electrophilic addition reaction that will proceed with the formation of a pi complex. Here we are. Let us consider the reaction between ethene plus bromine in carbon tetrachloride as a solvent. This is going to give us what is the mechanism for this reaction? Mechanism. Now CH2 Now you see that bromine and bromine atom here. Remember the solvent here is carbon tetrachloride. Bromine and bromine atom here, they have the same electron negativity. So neither of these two atoms will be able to pull this sigma bond more or less toward itself. But it is imagined that the electron density that surround these two atoms at one point begin to shift towards one end. It's instantaneous. That's why we call a kind of force will be generated here. This force is called the weak van der Waals force of attraction. You take note. So here you observe that one. If the electron density of one of the bromine atom turn to shift towards one end instantaneously, then there will now be a kind of attack that the pi bond will immediately instantaneously try to attack the bromine atom, and as it is doing so, this other sigma bond is carried to the bromine atom. This is what we get. This is what we observe. This is now going to produce a bond is established now between this carbon 1 and the bromine atom, and we have and this bond, we expected a bond to be established between this carbon and this bromine as we saw above, but this isn't going to be the case. Now this is not going to be the case. Now you take note. Let me show you exactly what happens. That is what we expected, but that is not what it's going to be. Now instead we will observe that since the two carbon atom has the same strength to receiving this bromine atom, now this reaction will be such that the bromine atom now will be shared between the two atoms, the two carbon atoms, equally. Remember that this bromine is coming with a positive charge. There's a slight positive charge here, but we don't put it because this is not a polar molecule. So there's a positive charge here, and then remember that there will now be the other bromide that is negative. This is what we call a pi complex. This is a pi complex. Now look at what happens. This pi complex in the presence of the bromide negative. Now look at what happens. Remember that this bond here is such that it is being pulled towards the bromine atom. The positive bromine here is being pulled towards this positive center, and so the bond causes this carbon to be polarized. It causes this carbon to look like positively charged. So you can see very clearly that since this carbon now seems to be positively charged, this negative charge electrons can now come to establish a bond there. You see it very clear. And now we are going to have this bond here will now be carried to the bromine atom, and we can now confidently write it as a bond now established between this carbon and the bromine atom, and another bond is established between this other carbon and the bromine atom. This is 1,2 dibromo. 1,2 dibromoethane is formed. Remember, if you are new here, you can consider subscribing. We want to look at nucleophilic addition reaction. Nucleophilic addition reaction. In this reaction, a nucleophile is going to be added to an electron deficient center of an unsaturated compound, an electron deficient center of an unsaturated compound. Let us take an example of this kind of reaction as you see. Imagine a compound like an aldehyde, like let me just take this compound. We popularly call it ETHANAL. If you react ETHANAL with hydrogen cyanide, we are going to produce CH3 This is the compound we are going to produce, and this compound is 2-hydroxyl propano nitrile. 2-hydroxyl propano nitrile. Now look, this is a nitrile. Now how is the mechanism? The mechanism of this reaction, we first produce our nucleophile. Which we need very seriously. This is our nucleophile. Now look at what happens. The carbonyl compound here, this aldehyde. Okay, permit me to write it this way so that it will be very clear. Now you know that the electron negativity of oxygen is higher than that of carbon, and therefore this oxygen tends to pull this pi bond more toward itself. And so when this happens, this carbon now becomes slightly positive. This carbon becomes slightly positive. So the cyanide now can quickly attack this carbon. This N is slightly negative, this carbon is slightly positive. So this cyanide quickly come and establish a bond with this carbon, and this pi bond is carried to the oxygen. When this happens, we are going to produce this N now is negative, hydrogen is cyanide. Yeah, that is a cyanide group. Now you see it has been added to the carbon. It has been added to the carbon deficient center of an unsaturated compound. So in the presence now of this proton, you can now see that this negative charge can pick up the proton, and this is going to give us our desired compound. This is our 2-hydroxyl propano nitrile. 2-hydroxyl propano nitrile. This is the mechanism. This reaction is called nucleophilic addition. You are adding a nucleophile to an electron deficient center like carbon here in a carbonyl compound. This reaction is what we call nucleophilic addition reaction. Thank you. If this video you did like it, you consider subscribing to the channel Remember, this is Marquardt Phosphate Academy of Science and Technology. We can teach you online all the science subjects, including computers, ICT, chemistry, physics, math, further mathematics, additional mathematics, in as much as you have internet and you are ready to study with us. We are right there. We work 24 on 24 in this academy. Thank you very much. If you did enjoy our lesson, consider subscribing. Bye bye for now.